All right, in this video, we want to prove this inverse trig ratio over here. Basically, the sine inverse of 1 over root 5 plus the sine inverse of 1 over root 10 equals to pi over 4. And we're not allowed to use a calculator for this question. So if I take a look at this over here, none of these values are really in my exact triangles, so I can't use the values straight away. So the first thing I'm going to do is I'm just going to define theta as sine inverse of 1 over root 5. And I'll define beta as sine inverse of 1 over root 10, basically these two angles over here. So now I can just rewrite this formula as theta plus beta equals to pi over 4. So now I basically just have to prove this right over here. So let's take a look at this. Theta is sine inverse of 1 over root 5. So if I move the sine to the other side, I get sine theta equals 1 over root 5. And I'll do the same for this one. So sine beta equals 1 over root 10. So now I can draw out my right angle triangles based on these two sine identities over here. Draw my two triangles like this to begin with. Make the right angles over here. I'll just make the bottom over here theta and the bottom over here beta. It doesn't really matter if you make the bottoms or the tops, but just kind of stay consistent. So sine is opposite over hypotenuse. So my opposite is 1 and my hypotenuse is root 5. I can find my adjacent side now by using my Pythagorean theorem. So a square plus 1 square equals root 5 squared. A square plus 1 equals 5. A square, I'll subtract the 1 on the other side, equals 4. If I square root both sides, I'll get a equals to 2. So the bottom side over here is 2. So the exact same for this one. Sine beta is opposite over hypotenuse. Find this side again using Pythagorean theorem. Exact same steps. Oops, that's a 10 as the previous one. And we get the bottom side to be 3 in this triangle. Now, once we've reached this point here, we have quite a bit of information, but we still have no idea how to solve this. You could use trig identities, but if you look at the two triangles, you'll notice that this side is exactly the same length as this side, and we're trying to figure out a way to get theta and beta together because we want to basically prove theta plus beta equals pi over 4. So in order to get theta and beta together, I can actually stick these two triangles together by attaching this side. So I'll draw that out right over here. So basically this is theta, and this triangle, I'm going to mirror it. So this is beta. So that side over there is root 5. This is root 10. I have the same height in both triangles as 1. And then this bottom is 2 and this bottom is 3, which means that the total bottom is going to be 5. So now we have an obtuse triangle, and we have theta and beta, and we need to find theta plus beta. If I look at all the information in this question, I have all three of the sides of the main triangle. And when you have all three sides of the main triangle, you know that you can use cosine law to find an angle. I'm specifically going to find this angle over here. And then once I find this angle, I'm just going to subtract pi, which is the total of the angles in the triangle from this angle, that's going to give me theta plus beta. But I'll show you the steps so it makes a bit more sense. Let's call this gamma over there. So I'm going to use cosine law to find gamma. So this is going to be my a square. This is my b square. And this is my c square. I'm not going to write down the cosine law because at this point you should know it really, really well. Minus 2 times b times c cos gamma. So I'm trying to find gamma in this problem. Let me simplify this equation over here. That's 25, that's 5, that's 10, and then root 5 times 10 is root 50 cos gamma. Still got to simplify a lot more to find gamma. So 0.5 equals 5 plus 10 is 15. And then root 50 can be simplified to 25 times 2. Again, I'm not going to explain simplifying radicals because that's something you should already know at this point. Then I'll subtract the 15 on this side here. I can't combine these two because this is multiplying here. So 25 minus 15 is 10. And I'll simplify this square root. So if I square root 25, it becomes a 5. If I multiply 5 on the outside, this becomes negative 10. There's still a 2 on the inside of the root. Then cos gamma. Then I'll divide both sides by negative 10 root 2. This 10 and this 10 cancel, and I'm just left with negative 1 over root 2 equals cos gamma. So now I need to solve this. I'm going to use my special triangles over here because this is the case of a special triangle now when you have 1 over root 2. The first thing I'll do is my cast rule. Cos is negative in the second and third quadrant. However, if we're thinking about this question specifically, what do the angles in a triangle equal to? Theta plus beta plus gamma has to equal to pi because the total of the angles in a triangle equals to pi, which means that we only need to worry about the first two quadrants because that's pi right over there, which means that we can disregard the answer from the third quadrant because the angle will be way too large to fit inside a triangle. So now I'm going to draw my triangle over here. That is angle gamma over there. Looking at the relate acute angle, I can set my ratio now. So cos is adjacent over hypotenuse. So my adjacent is -1. My hypotenuse is root 2. And then this also, if you remember your special triangles, it's 1. And this special triangle over here has this as pi over 4. So the acute angle is pi over 4, which means that we can calculate gamma, the obtuse angle, as half a circle, which is pi, minus pi over 4, which is 3 pi over 4. Now that I've found my gamma, I can use it to find what theta plus beta is. Over here, I'm going to replace my gamma with 3 pi over 4. Then I'm going to subtract it on the other side. Pi minus 3 pi over 4 is just pi over 4. And now, as you can see, I've pretty much proved the identity. We know that theta is sine inverse of 1 over root 5. We defined that at the start of the question. And we know beta is sine inverse of 1 over root 10. And we know this equals to pi over 4. So we've proved the inverse trig identity or basically equation given in the question. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.